Welcome back to the Deep Dive. We're here again to unpack the latest industry shifts, giving you what you need to know about today's tech landscape. And today, well, we're tackling something huge. AI engineering. It's this whole new field that's really changing how software gets made. The generative AI explosion, it felt like whiplash for a lot of people. And it wasn't just the models getting bigger. Everyone kind of saw that coming. I mean, back in 2012, the AlexNet folks basically said they were just waiting for faster GPUs, bigger data sets. They weren't wrong, but the real surprise, and this comes straight from our sources, was just how many applications suddenly became possible. The utility just exploded.
Exactly. And that explosion of applications, that's really the heart of AI engineering, or AIE as people are calling it.
Yeah.
It's fundamentally the whole process end to end of taking these huge pre-trained models, foundation models, and actually making them work for real problems. It's shifted from pure research to, well, the practical side, the messy, get it into production side of AI.
And the scale of this shift is just incredible. You look at the engineering world, and AIE is like one of the fastest growing fields ever. Think about this. 4 open source AIE tools, AutoGPT, Stable Diffusion Web UI, LangChain, Llama, they got more GitHub stars faster than Bitcoin did.
Wow, faster than Bitcoin.
Yeah, and they're on a trajectory to actually overtake huge web frameworks like React and Vue. It's not just some fad, it's a fundamental pivot.
Definitely. And to really get AIE, you first need to grasp the models themselves. We've moved past just large language models, LLMs. We're solidly in the era of foundation models, FMMs. And that includes large multimodal models, LMMs. So these aren't just text anymore. They handle images, video, even really complex stuff like protein structures. The big change from older ML is moving away from single task models, where your sentiment analyzer couldn't do translation. Now we have these general purpose models that can tackle a whole range of things.
Which totally changes the engineering job, right?
Right.
Traditional ML involves so much grunt work, annotating tons of usually tabular data, figuring out features, training models from scratch.
Right. Painstaking work.
But with AIE, you're generally not training that base model. You're steering it, guiding it.
Exactly. Steering is a good word. And that means learning completely new skills. Things like prompt engineering, sure, but also context construction and this thing called parameter efficient fine-tuning, or PEFT. Let's pause on context construction for a sec. Prompt engineering gets a lot of buzz, but building the right context, that might be even more critical. It's like giving the AI the perfect cheat sheet before it even tries to answer.
Okay, so you're not fundamentally changing the AI's brain, you're just giving it really good reference material for the specific task.
Precisely. And the results are already staggering. Take education. FMs let you truly personalize things. An AI can summarize, say, the Roman Empire, okay, standard, but then it can tweak that summary for a student who loves animals, using animal analogies.
Or translate math equations into Python code for someone who thinks better in code.
Exactly, that kind of adaptation.
And the Chegg example you mentioned earlier is just stark. A homework help company's stock price goes from $28 to $2 basically overnight because students just switched to using AI.
Yeah, it's maybe the clearest sign that this isn't some future prediction. It's happening right now. It's disrupting markets now.
Absolutely.
And we also see AIE tackling just the sheer volume of information out there. Summarization, talk to your docs. These are becoming essential. Something like 74% of generative AI users are using it just to distill complex stuff. It's almost a coping mechanism for information overload.
Okay, so the potential is huge. The disruption is real. But what are the limits? Things can't just scale forever, right?
They can't. And you're right. Bigger models generally do perform better. We went from GPT-1's 117 million parameters, which sounds tiny now, to models with over 100 billion parameters being common. But we're hitting some hard walls. 2 big ones, really. First is data exhaustion.
Data exhaustion? You mean we're running out of stuff to train them on?
Sort of. We're creating training data so fast, we're actually using up high-quality human-generated data faster than new data is being created, which immediately gives a massive advantage to companies sitting on huge piles of proprietary data. Copyrighted books, private medical records, things like that.
Okay, data scarcity. What's the second bottleneck?
The second one is just raw electricity, power.
Yeah, the energy costs.
Yeah. Data centers already use maybe 22% of global electricity. Some estimates say AI could push that to 4%, maybe even as high as 20% by 2030.
20%? That's a lot.
It's a huge number. The costs, the grid stability, the environmental impact, it's becoming a major friction point for just scaling these things bigger and bigger.
Okay, so physical limits like data and power are slowing down. The bigger is better trend. But let's talk about the models themselves. How do we get them to be, well, useful and safe, not just predicting the next word on a web page?
That's exactly the job of post-training and alignment. See, the initial pre-trained model, it's just really good at text completion. So that's it. Left on its own, it can be unsafe, unhelpful, maybe even rude. It talks like the internet, basically, not like a helpful assistant. So alignment is crucial. There's that popular meme, the Shoggoth with the smiley face.
Yeah, the idea of this powerful, unknowable thing hidden behind a friendly mask. It's a bit dark, but apt.
It kind of is apt, yeah. We're
Yeah.
essentially putting this carefully crafted user interface, the smiley face, on top of that raw predictive power. It's about making it behave predictably and safely.
So how do you actually do that? How do you attach the smiley face?
It takes a lot of human effort. The first step is often supervised fine-tuning, or SFT. You basically get humans to write lots of high-quality examples, pairs of prompts, and ideal responses, and you train the model on those. But it's expensive. Just the labeling for the 13,000 examples used for Instruct GPT costs something like $130,000, just for the human work.
Wow, okay, that's pricey.
Very. Which is why the field quickly moved towards using a reward model, or RM. This is usually part of reinforcement learning from human feedback, RLHF. Instead of asking humans to write perfect answers, you show them two different AI-generated answers and just ask, which one is better?
Ah, so comparison is easier for people than scoring from scratch.
Much easier and more consistent. You train the reward model on these preferences and then use that RM to guide the AI's learning. It's more scalable.
Okay, so alignment helps make them follow instructions. But even aligned models are still weird sometimes, right? They're based on probability.
Fundamentally, yes.
Yeah.
Their output comes from sampling, calculating the probabilities of all possible next words or tokens, and picking one. This probabilistic nature is actually amazing for creative tasks. Brainstorming, art generation, writing fiction, fantastic.
Right?
But for almost everything else, especially building a reliable product, it can be a nightmare.
Because you can't guarantee the same output twice. That must drive engineers crazy.
It does. It leads to two major problems. The first is just plain inconsistency. Same input, slightly different output. Users notice that. It feels unreliable.
So how do people deal with that? Caching, fixing the randomness somehow.
Yeah, exactly. You often fix the sampling parameters like the random seed,
Mm-hmm.
or use caching aggressively so repeat requests get the exact same answer.
Okay, inconsistency. What's the other big headache?
The infamous one, hallucination. The model just confidently makes stuff up, fabricated facts, invented events.
Why does it do that? Is it lying?
It's not really lying in the human sense. It's just generating the sequence of words that seems most probable based on its training data, even if that sequence doesn't correspond to reality. There's this interesting hypothesis that the model sometimes can't tell the difference between the external data it was trained on and the text it generates itself, like a kind of digital self-delusion.
Huh. That's a bit unsettling. So how do engineers try to control this randomness beyond just caching? Are there specific controls?
Absolutely. Sampling controls are vital tools in the AIE toolkit. The most famous one is temperature.
Temperature, like heating up the AI.
Sort of. Think of it as a dial for creativity versus coherence. Higher temperature means the model is more likely to pick less probable words, more randomness, more creativity, but potentially less logical.
Right.
Lower temperature makes it stick to the most obvious, high probability words, more consistent, more predictable, maybe a bit boring.
So where do you usually set it?
Well, for creative stuff, the sources often suggest starting around 0.7. For factual, consistent answers, you'd go much lower, maybe even close to 0.
Okay. Temperature. Any others?
The other main one is top-op, sometimes called nucleus sampling. This one's a bit more dynamic. Instead of looking at all possible next words, it considers only the smallest set of top words whose combined probability adds up to a certain threshold, like, say, 90% or 95%.
So it narrows the options, but still allows for some variety within the most likely choices.
Exactly. It stops the model from getting stuck on just the single most obvious word, while also preventing it from going completely off the rails with super low probability choices.
Right. Temperature and top-up. Key tools for managing the inherent randomness. Okay, so let's get practical. An AI engineer starts a project. They have a foundation model. What's the big decision they face first?
The fundamental choice really is, do we change the context we give the model, or do we change the model itself?
Okay, change the context or change the model. What does changing the context mean?
That primarily means using RAG Retrieval-Augmented generation. This pattern really emerged first because, frankly, it's easier, cheaper, and often safer. RAG is for facts. The idea is simple. Before asking the model a question, you first retrieve relevant, up-to-date information from an external source, like your company's internal wiki, product docs, whatever.
And you stuff that information into the prompt.
You basically inject it into the prompt context. So you're telling the model, okay, answer the user's question, but base your answer on this specific information I just gave you.
Ah, so it limits the model's ability to just make things up, because you're providing the ground truth right there in the prompt. It helps with hallucination.
Precisely. It anchors the model to verifiable facts. It's usually the first thing you try.
Okay, so RAG handles the facts. What if my problem isn't about factual accuracy, but about getting the AI to output things in a very specific style or format, like generating code that has to compile or complex JSON?
That's where fine-tuning comes in. Specifically, these newer, more efficient methods like PF, parameter-efficient fine-tuning, and a popular technique called LoRa. Fine-tuning is for form. It's about teaching the model a specific structure, syntax, or style that might be rare in its original massive training data.
So if I need it to consistently generate, I don't know, legal documents in a very precise format or speak like a specific character?
Exactly. Or generate complex technical diagrams described in a certain language, or output HTML that renders correctly every single time. Things where the structure is just as important as the content.
And the parameter efficient part means you're not retraining the whole giant model, which would be insanely expensive.
Right. PEFT methods like LoRa let you adapt the model's behavior by training only a tiny fraction of its parameters. It's much faster, much cheaper, and makes fine-tuning practical for many teams.
So generally, start with RAG for facts, maybe layer in fine-tuning if you have specific form or style requirements.
That's a very common workflow, yes.
No, okay, makes sense. You build your system using Erga or fine-tuning or both. Then comes the hard part. Our sources dedicate 2 whole chapters to this. Evaluation.
Oh, yeah. Evaluation is it's the biggest headache in AIE right now, honestly. It's so tricky that many teams, especially early on, kind of just eyeball the results or rely on anecdotes, word of mouth. Does it feel like it's working?
Which isn't very scientific or scalable.
Yeah.
We need objective measures.
We desperately need them. And we have some, but they often have their own quirks. Take perplexity, PPL.
Perplexity. That measures how surprised the model is by the next word, right? Lower is better means it's good at predicting.
Usually, yes. Lower PPL generally means better predictive accuracy on the training data distribution. But here's the kicker. PPL often goes up after you do alignment fine-tuning, like SFT or RLHF.
Wait, what? You spend all this time and money aligning the model to make it better, and its perplexity score gets worse.
It seems counterintuitive, right? But think about it. Alignment forces the model to follow instructions and be safe, even if that means choosing slightly less probable words than raw prediction would suggest. There's this idea of entropy collapse. You're trading some raw predictive power for usefulness and controllability. So yeah, PPL might go up, even though the model is subjectively much better for the user.
Huh. Okay, that's a weird one. What else do people use for evaluation? I've heard about using AI to judge other AI.
Right. AI is a judge. The idea is you use a very powerful state-of-the-art foundation model like a GPT-4 to evaluate the output of a smaller model you're building. You ask the judge model things like, is this response factually accurate? Is it helpful? Is it toxic? And you use its scores.
That seems convenient, but also kind of circular, like asking a top lawyer to grade another lawyer's work. Are you getting an objective measure or just the top lawyer's opinion?
That's exactly the criticism. It can correlate well with human judgments, but it's not a standardized benchmark. It adds cost, it adds latency to your evaluation pipeline. And yeah, it feels a bit tautological. Is the judge AI really measuring quality or just agreement with its own internal biases? It's useful, but it's not a silver bullet. It shows how far we still need to go on reliable evaluation.
So wrapping this part up, this deep dive really underscores that AI engineering isn't just coding. It's this complex practice of adapting these massive FMs. It involves mastering prompt engineering, context building with RGRI for facts, and careful selective fine-tuning with things like PEFT and LoRa for form, and then wrestling with the huge challenge of evaluation.
Absolutely. And maybe one final thought to leave you with, tying back to the probabilistic nature and the scaling issues we discussed. We talked about data exhaustion, electricity being bottlenecks now, but there's a potential future bottleneck lurking: model collapse.
Model collapse. What's that?
Think about it. Increasingly, the inner data these models are trained on contains output from other AI models. Grok, for example, was reportedly trained on web data that was already full of ChatGPT outputs. If future models are recursively trained primarily on AI-generated data rather than original human data, there's a risk they might start to
Forget.
forget,
Forget what?
Forget the nuances, the diversity, the rare patterns present in the original human data distribution. They might converge on outputting only the most common, average stuff, losing fidelity and eventually degrading in overall quality and capability. It's like making copies of copies. Eventually, the quality degrades.
So training AI on AI data could lead to dumber AI.
Potentially, yes. Or at least less diverse and less grounded AI. This tension between using abundant synthetic data versus preserving the integrity of scarce, high-quality human data, that's going to be a huge challenge going forward.
That's a fascinating and slightly scary thought to end on. The risk of AI eating its own tail, potentially degrading itself over time, something for all of us working in this space to really think about. Definitely explore that concept of model collapse that could have major long-term implications. Well, that's all the time we have for this deep dive. Thanks for joining us. We'll catch you next time.